We're on section 5.2, and we're studying plants and how plants perform life functions. One of the most important functions that a plant is going to perform is photosynthesis. And of course, we talked about photosynthesis in yesterday's notes, and we focused on this idea of this picture. And this picture should be really helpful for you. You can see that coming into the leaf are going to be carbon dioxide gas and water. And we talked yesterday about how does water get up to the leaf. So this is a little bit of a review. Water is transported up to the leaf using some cells called xylem. Xylem carries water up. Carbon dioxide will come into the leaf through a tiny hole called a stomata. And so coming into the leaf are carbon dioxide and water, and the plant will use light to build a sugar and release oxygen. So it's really important that as you are studying in this unit, that you really study what photosynthesis is, because it's one of the most important life functions of a plant. It's how a plant survives. Without photosynthesis, plants don't have any of the things that they need to live. And of course, we can relate this to the structures of a plant, looking at how does a chloroplast help the plant perform photosynthesis. We talked about vascular tissue, these tubes or vessels that can move water up and food down. We talked about stomata, tiny little holes that will allow gas exchange. And today we're going to talk about how plants perform regulation. Things are going to change in a plant's environment. On a daily basis, the plant has light during the day and dark at night. And so plants need to be able to respond to changes in their environment. So we're talking about some growth response. Plants use hormones to regulate their growth and response to the environment. So we want to put a big star by this statement. Plants use hormones. When you hear the word hormone, you probably think of like a teenager and how hormones rage in their bodies. But hormones are really just signaling molecules. They're just a molecule that can send a message. And so we're going to see three main signaling molecules: ethylene, cytokinin, and auxin. Ethylene is going to be really important for ripening fruit. We'll get to talk about fruits tomorrow when we talk about reproduction. Did you know that when you eat a fruit, the plant is tricking you into helping it reproduce? Cytokinins. Now this one should look pretty familiar to you. If you'll underline cytokin, it sounds like cytokinesis, which is how cells actually divide at the end of mitosis. So a good little review there of cell division. Auxin is the one that we're going to focus on. Auxin elongates the cells so that they can grow in response to stimuli. And stimuli are changes in the environment. So if something changes in the environment, the plant can respond to that. We're going to see three main responses. Phototropism. Well, we already know that photo means light. Gravitropism. This one should be pretty easy, like gravity. This is growth in response to gravity. Now, if you look at this little seedling, you can see that if light is coming in from this side, the plant will bend towards the light. It will grow towards the light. The roots, however, do not grow towards the light. The roots will grow away from the light. When we talk about gravity, the roots will grow towards gravity, but the stem will grow away from gravity. So even though plants don't have eyes, they're able to respond to the environment through the use of hormones. The last one I want you to put a star by, not necessarily because it's the most important, but because it's probably the most difficult to remember. Thigmotropism is growth in response to touch. Next to this, if you'll write vines. Vines have really flexible stems, so they can grow around and up an object. And so vines show what are called thigmotropism. And so when we talk about Sturmger, synthesis, transport, excretion, next we have regulation, and this is how plants regulate or control their growth patterns. Next is nutrition, and we already talked about this a fair amount because we said that plants provide their own nutrition through photosynthesis. And so this is a good time to stop and see if you remember, what is photosynthesis? I need light because it's photo. I'm making something. What is it that I'm making, and what else do I need to make that? Remember, plants make their own nutrition. They make their own food, and we're talking specifically about sugar. This whole sentence is underlined because it is pretty important. We have this new word, autotroph, and it means to self-feed. So plants are considered autotrophs. They self-feed, and they're important parts of the food web. So you can see that plants use sunlight to build their own food. They use carbon dioxide and water to build their own food. And now they have glucose or other organic molecules. Well, guess who's going to use that glucose? Animals. So when we study food webs in the next unit, you'll be reminded from what you learned in earth science about how food allows us to transfer energy. The last part that we're going to talk about is going to be growth and development. And so most plants, in just a second, as soon as I can bring my pen back up, we're going to put a star by most. Most plants begin their lives as seeds. So we're going to put a star by most because some plants don't have seeds. Some plants, like ferns, do not have seeds. They have something else called spores. But a seed is actually an adaptation. It helps it better survive and reproduce. And so we're going to be talking about these 4 parts of a seed. Most plants begin their lives as seed. The embryo is dormant until conditions are optimum. What we mean by the embryo is the baby plant. And so number 2 is the embryo leaf, the first leaf of the plant. And number 3 is the embryo root, the first root of the plant. And so inside the seed, even though we can't see it, is a tiny little baby plant. Now, providing food for this seed, that's going to be really important because this seed is going to be underground. And when it's underground, it doesn't have light and it can't perform photosynthesis. So number 4 is a food source until growing above ground. Above ground. A seed that is in the dark soil or even in the middle of a fruit can't grow on its own because it doesn't have sunlight. However, if we give it a food source inside the seed, then it will have food to grow until it reaches large enough to perform photosynthesis. The most important part of the seed is called the seed coat. If we just left this little baby plant and its food out in the open, animals would eat it or it would dry out. And so the seed coat is actually there to protect the juvenile plant. And so plants without seeds that have spores, if you don't have this seed coat, you'll dry out. However, having the seed coat, the baby plant, and the food source means that this is a good adaptation for better survival. And so this is the main idea of how plants are going to grow. We'll be talking about reproduction later, and so this is where we're going to stop. You do not need to take the note